If there's one thing you should take away from this talk, it is that fragments are not for reuse. I might make you guys repeat that as a, oh, thank you. Yeah, if there's one thing to take away, they're not for reuse. So here's the agenda. First, we're gonna talk about what is a fragment according to the spec. Secondly, we'll talk about why it's bad to reuse fragments, or as I like to say with glee, why the spec is wrong. And then thirdly, how to actually use fragments. And I'll give you 3 tips based off what we found to work well at Meta. And then lastly is a section called But What About?, which is where I try to anticipate your objections and questions and answer them. What is a fragment? Here are the first 2 sentences from the spec in the section describing fragments. The first sentence here, fragments are the primary unit of composition in GraphQL. We have no objection to, 100% agree. We use fragments aggressively at Meta to compose our queries. The issue is with the second sentence. Fragments allow for the reuse of common repeated selections of fields, reducing duplicated text in the document. Wrong. So I think there's 2 things right here that we disagree with. The first one is the word reuse. So remember, fragments are not for reuse. Reusing fragments actually means you're not getting the full benefits of GraphQL. We'll get into why that's the case just in a second. The second is the idea that the primary benefit of using fragments is reducing duplicated query text in your executable documents. I would say this is vastly underselling the value that fragments provide. Instead, this is how I would write this sentence to better describe what fragments enable. So instead of reuse, fragments allow for the modular definition of each function or component's data needs. And then the reason why you should write fragments that way is to help prevent over and under fetching. So overfetching is fetching data that you don't need. Underfetching is accidentally not fetching the data that you do need. So the first one is inefficient, right? Because we're computing things and sending them down and then we don't use them. And the second actually breaks your products, so it's really bad. As promised, our next section is why exactly it's bad to reuse fragments. So why am I really harping on this point? First, to clarify, this is what I mean by reuse in this talk. So we are not talking about spreading a fragment in multiple places. That is totally fine. Bad reuse is referring to 2 different functions or components relying on the same fragment to express their data needs. So for example, I think Benji referred to this in a panel as like a God fragment. You know, you have like a long list of fields that are being fetched everywhere, and you're like, great, I'll just throw them into a fragment and use that everywhere. That's the type of reuse that leads to overfetching. And let's get into why. So reason number 1, reuse is bad. Even minimal reuse can cause overfetching. Here's an example. So we have 2 functions. Both at the moment are accessing author name and content text off of a post type and just creating a string. So they're accessing the same fields right now, so let's go ahead and take the spec select or suggestion and write a fragment for these functions. And it fetches author and content off of post. Nice, right? Wrong. Let's say down the line, you know, like tomorrow, in a couple of hours, if you're at Meta even, we decide format post for feed actually wants to use a new field on post, timestamp. So we add timestamp to our fragment, so we start fetching it from the server. Some of you may already see where this is going, but to make this extra clear, you might have 2 queries, right? One for notifications, one for feed query, and they were both spreading that fragment. And now notification query is overfetching, right? It's now fetching timestamp, even though that's not going to get used on that surface. And the only way you can get rid of that overfetching is by splitting this into 2 fragments now, one for each function. And then another way you could look at why this is bad, oops, sorry, I have to face forward, is you have 2 independent functions here. And what you've done by creating a fragment that these 2 functions share is add an implicit dependency where there shouldn't be one. And you might say, big deal, in this case, it's just 1 field. And what I will tell you is that if you have a lot of GraphQL with lots of people changing it constantly, you're going to end up with a lot of overfetching from this sort of fragment reuse. Second reason reuse is bad, which is also related to overfetching and kind of a tooling point, is that if a fragment is only used in one place, it's really easy and fast to know if any fields in the fragment are no longer needed. On the other hand, if you have a fragment that is used willy-nilly throughout your entire code base, it's going to be difficult and, more importantly, slow to detect when fields in the fragment are no longer needed. And the reason I'm emphasizing speed here is being able to quickly detect if any fields are unused enables things like unused field linting, which, for example, Relay has support for in ESLint. And let me tell you from our experience, being able to continually prompt people to remove unused fields makes a huge difference over time to make sure your queries are efficient and prevent bloat. And I would go as far as to say as you maybe are not getting the full value of GraphQL if you're unable to do this sort of unused field linting. So that's why reusing fragments is bad. Now let's get into how you should actually use fragments. A reminder from earlier, the high-level idea for how we like to think about fragments is as modular definitions of each function/component's data needs, and our main goal is to not over or underfetch, which I imagine is probably everyone's goal. And one thing I'll point out is this way of thinking about fragments actually aligns better with general GraphQL design principles. So these are also from the spec. So namely, writing a fragment per component is how you structure your requests to echo the hierarchy in your views. And doing so helps ensure one of GraphQL's greatest value adds, which is the ability to fetch exactly what you need, aka no overfetching. So how do we implement these principles in practice? I'm going to give you 3 concrete tips from how we use fragments at Meta. So this is just a quick summary. We'll go into detail for each of these in the next series of slides. But first, to prevent underfetching, use fragment models. Then, to prevent overfetching, co-locate your GraphQL with where it's used and write GraphQL that looks like your code. That's the no reuse part. So tip number 1 is to use fragment models, not type models. So you might ask, what is a fragment model? A fragment model is a data model generated based off a GraphQL fragment. You can only access a field if it's in the fragment. On the other hand, a type model is a data model generated based off a GraphQL schema type, and you can access all fields defined in the type. So here's an example. We have 2 things here, right, we can use to generate our data model on the client for film list item component. The first is the schema type for film. And this is actually, kind of most people's first intuition for what you should use to generate your type. So it's the film type. It has all the fields one could fetch on film. The second is the fragment, which only has the title and director fields. We're using Relay here, which means we're using a fragment model. So you can see here in Relay's code gen that we only have accessors for director and title. So if you try to access episode ID, you will actually get an error because it's not in the fragment, and therefore it's not in your generated model. And this is good because it prompts us to actually add episode ID to our fragment, ensuring we actually fetch the data we need. So that's the preventing underfetching part. And you could see if we didn't error here, there's nothing to ensure the data that we need actually gets fetched. So we could end up underfetching and breaking our product. And then a side note, kind of outside the scope of this talk, is that fragment models can actually use schema nullability to type their accessors instead of everything being nullable. So if you have a type model, right, you have all the fields on that type, everything has to be nullable because you're not always fetching all the fields on that type. Whereas if you are using a fragment model, you're guaranteed to be fetching that data, so you can use schema nullability to type your accessors. So that was tip number 1, use fragment models. Now tip number 2 is to co-locate your GraphQL with the code that uses it. So co-location entails 2 things. The first is that the GraphQL for a piece of code should be located next to that code. So in Relay, it's actually in the same file. And the second is that the GraphQL for a piece of code is not usable outside the context of that code. So again, let's look at an example of this in practice. So we're using Relay here again. We have that same film component, except now it has a child character component. Notice how each component has its own fragment. So that's the located next to each other part. And also notice that even though film item includes character item as a child fragment spread, the film component cannot access character name. So you might ask, why is this good? It's a child fragment spread, right? So anytime you're spreading that parent fragment, you're going to get that data. So why can't you access it? So the reason this is good is if one day you decide you want to delete the character component from that film component, you can also just delete that spread. And you can imagine if film could reuse the fields in character, aka its child fragment spread, you would end up just keeping that spread there, and you would end up overfetching, because there's stuff in that character fragment that you don't actually need. So to reiterate, collocation is good because it ensures each function/component has a unique fragment to represent its data needs, aka no reuse, and to prevent overfetching. And secondly, it's actually really nice for developer experience. It makes it really easy to find the GraphQL that has to be updated when your data needs change. And as you can maybe tell from the examples I'm using, if you take fragment collocation and fragment models and put them together, you essentially get Relay's data masking. And while I'm speaking of Relay, if you're interested in hearing more about other great ideas and innovations in Relay, you can go see Jordan's talk later today. And in addition to touching on how Relay has helped to really pioneer the use of fragments, there's a lot of other smart stuff that Relay does that you can learn about later this afternoon. All right, back to this talk. So tip number 1 was use fragment models. Tip number 2 was to co-locate your GraphQL with the code that uses it. Tip number 3 is kind of an extension of tip number 2, and it's to write GraphQL that looks like your client code. So this is how you write GraphQL that looks like your client code. Each function or component turns into a fragment co-located with the logic it corresponds to. That's kind of that co-location point from before. Secondly, function calls/child component usages turn into fragment spreads. And then what you access on your data model turns into the fields on your fragment, no more, no less. In fact, if you remember this tip from earlier, we actually got this wrong, and we have had to migrate from type models to fragment models. And the reason I bring this up is that in the process of migrating from type models to fragment models, we had to write a lot of fragments. And what we found is you can actually generate fragments from ASTs. So here's an example of how you can literally translate some product logic into GraphQL. So you have a function here called format post that takes in a post type model. And you want to write a fragment for this function so we can instead use a fragment model in this function. You can get the AST for the function and translate different parts of it into GraphQL. So, namely, the function itself corresponds to a fragment definition. All the field accesses on the post type model, author and light count, turn into fields you fetch in your fragment. That function call where you pass that post object into a different function turns into a fragment spread, where the fragment you are spreading represents the data needed in the function you are calling. And if you really want to go nuts, the ternary operator in the function, or any conditional operator, can turn into a skip or include. So you're only fetching the data when you actually need it in the implementation. So it's kind of neat, right? So those are our 3 tips for how to use fragments to prevent over and under fetching. Now it's time to get into some objections you might have to our recommendations. This first objection comes from the spec. So you might ask, but what about reducing duplicated text in executable documents? If I can't use a fragment to throw all my common fields into, won't my queries be larger? So here are some suggestions for that. If you're worried about server execution cost, just a friendly reminder that the field collection stage during execution already ensures that duplicated fields are not resolved more than once. So even if you have a field occurring multiple times in your query document, it's only resolved a single time during server execution. If you're worried about sending large queries over the wire, use persisted documents. So a persisted document is, instead of sending like string queries as a JSON payload at runtime, you save your query on the server, attach an ID to it, and then at runtime, your client just sends that doc ID instead of the actual query. And what's more, persisting documents has some great security benefits, right? Because you can only accept queries from those IDs that the server recognizes. Benji actually gave a great talk about this last year called Techniques to Protect Your GraphQL API if you're interested in the security reasons why you should use persisted documents, aka trusted documents. Lastly, if you're worried about the cost of parsing a larger query, that is fair. And what I would say is if you are persisting your documents, like the tip from before, during that persist step, you can remove duplicated fields and optimize there. And then a more general point is that we have some pretty large executable documents, and this isn't a scaling issue that we have run into. And not saying we're the biggest, but we're pretty big. So, take some comfort in that. Another concern you might have is binary size. So we're telling you to use fragment models, which means generate a model per fragment. And then we're also telling you to write a fragment per component or function. So you might say that's a lot of generated model code, and you are correct. If you are sensitive to binary size, for mobile, what we have found is it is possible to write compiler optimizations that mitigate these costs. That's a different talk, I would say, so I'll give a quick high-level summary of how that works. I think the key observation is that fragment models are most important in your dev builds, because what you want, right, is for developers to get the signal at compile time when they haven't fetched a field they are accessing. At runtime in production, you can use type models, and it's totally fine. So you can leverage your compiler to kind of mush together all your models into a type model. And then for web, we actually haven't run into size being an issue. Potentially, gzip does a good enough job detecting common patterns, but we haven't had to engineer a specific solution for web. Lastly is generic interfaces. So while we recommend strict fragment collocation, there is a pattern you may come across where it's a little bit difficult to enforce collocation, namely generic interfaces. So here's another example. So here we have a function that takes in a list of films and sorts them by their created date. So following our tips for how you should write a fragment, right, the fragment we need to describe this function should only contain the created field, because that's the only data that this function needs. But now let's say you have two surfaces and they're both fetching a list of films. One surface is displaying director info for each film, let's say, and then the other surface is displaying character information per film. What if both surfaces want to use the logic to sort films by created date? It turns out what you have to do is something a little bit gross. It kind of looks like this. And it's not ideal, right? Because if you remember, we want our fragment to represent the needs of our sorting function. And now it contains all this other stuff. And what we need here is maybe something more like generic fragments or like fragment interfaces, something like that. Again, I would say that's a different talk. Matt Mahoney actually might be talking about it right now if you want to run out of the room to the 5th floor. If not, you can find him. He's another engineer at Meta to discuss during the conference. Okay, so now that I'm sure I've anticipated all possible objections, remember, very good, very good. Okay, yes, fragments are not for reuse. They are for accurate data requirement description and composition. Definitely not as snappy, but it's more accurate. Okay, oh yes, highlighting it because it's important. And then if you still have room in your brain, you can also try to remember the 3 tips for using fragments. So use fragment models, not type models. Co-locate your GraphQL with the code that uses it. And thirdly, write GraphQL that looks like your client code. All right, that's all. Thanks, everyone. All right, so we do have time for questions. Does anyone have a question? Yes.
What's your suggestion for fragments on mutations, and then especially mutations on things like lists, for example, a line item in shopping carts?
Oh, sorry. What? I feel like I'm missing a word. What's
your suggestion on using fragments for in mutations, and specifically mutations on lists, bring in replications of similar items?
Oh, interesting. I feel like, I think it's the same recommendation, maybe. I actually don't work with mutations as much. I feel like, I think generally, like, you want your GraphQL to correspond as closely as possible to the client code that's using it. So, like, whatever is, like, receiving the result of the mutation and, like, using it, like, what is in your mutation, I think, should just correspond to, like, the client code that's using that mutation. Does that answer the question, or yeah?
Well, for example, if I just a buy zone on the store, I don't need that information in response from that mutation, but of course I do need to update all the other elements of the website for when I use them, right? So for example, like using small fragment for my line item counter, well, like a little number on top of the basket, that's just one number. But then the quick cards, maybe that might pop up and show you the contents of the cart will need some more information. But you don't really know, like the button where you click add to basket, you don't know the other elements on the side.
Okay. Oh, what are you saying, Kawhi? Okay, yes. So for this, you should go to Sabrina's talk, yeah, which is on Wednesday, which is about client consistency. Yes, or yeah, I think because you're talking about like data changes and needing to like not knowing where in your client that data needs to be updated, right? Okay, yes, that is Sabrina's talk. So I'm punting to Sabrina on Wednesday. Client consistency, it's great. All right, yes? Okay, gotcha. So the question is, are these recommendations like more for development time as opposed to in production? I'm assuming you're referring to the recommendation for like reducing binary size, where we say fragment models are mostly important during developer time. Is that correct? I think, sorry, and the question is whether it's like worth using them given that at production time it's, or yeah, I guess. Okay, yes. I would say like the simplest use case is you're not too binary size constrained and you just use fragment models always. The part about actually using type models in production is only if you need to optimize for binary size. So the reason we did that is because we care about binary size on our mobile clients, so that's why we decided to mush them together. If you're not a binary size constrained app, I would just recommend using fragment models for simplicity. Yeah. Any other questions? Nope. Okay. Okay, great. It's lunchtime, so.